In this video, we're going to take a look at jumping right into RIP version 2 and getting that operational. So we're going to take a look at going through and on our connection at the sales office. So this guy right here, this is our sales office. We're going to configure RIP on these two routers right here, get them operational. See what we need to do to get that up and operational. I would recommend knowing RIP. RIP, I think it's a bad rap from a lot of people when it comes to friends don't let friends run RIP. Well, if you run with a lot of small customers like I do, a lot of customers can't run OSPF, EIGRP, BGP, so RIP is their friend. So what we're going to do is we're going to go through and get this up and running. Just a couple of specific pieces to it. So one of the things I'm going to do here is I'm going to do this. I'm going to go wacha. So I'm going to bring that over to this side and do this. I think it'll be much more easy to keep in play, and actually what I'll do is I'll bring this side down too, just so we can keep it up, just so you guys can see where I'm at with everything. Come on, there we go. Alright, so that's what we're going to do. So we can see where we're going to be configuring things, and as we're going through, we'll go back and forth. I think it'll make life a whole lot easier. And then I have our documentation back here. So, as I said, we're not going to do anything that isn't out of the ordinary. If I need to break protocol and go out to Google and take a look at something, at least then we'll be able to know where to go find it. So, we're going to configure RIP version 2, send and receive versions, look at how we can do that. Split horizon, obviously we're not going to have to do a lot with split horizon, but knowing how to turn it on or off. Unicast updates, broadcast updates, source validation, that type of stuff. Just the initialization. Like I said, I recommend everybody knowing how to do each one of these pieces piece by piece. You know where to configure it, all that type of stuff. So we're going to scoot over to 26, and we're going to go up here. We're going to ping 2624. About 27. What IP address? 2627. Oh. See, I already have a problem. So if I was to do a show CDP neighbors, I have 26 here, and he's located on gig 1/0. What if I go over here? 2420. So I typed in wrong. So this actually opens up a very, very good point. Source validation, if you don't know what that is typically used in dialer situations, or where you're dealing with, you have a RIP router on one end and another RIP router on another, and you go out and you're not in the same broadcast domain. So typically speaking, if you're not in the same broadcast domain, typically you're not going to be able to form routing adjacencies. So what we're going to do here is I'm going to attempt the source validation thing. It just happens to work out that 24 and 27 are the last third octet, and I didn't plan that out that way. It just happened to work out that way. So what we're going to do is we're going to go to global config, type in router RIP version 2 no auto. So we want to do that, and then what we're going to do is we're going to do the same thing on 27. One of the things on 26 that I'm going to do is I'm going to do a debug. Actually, no, hold on a second. Config T router RIP, and then network is 10, yeah, we're 10.0.0.0, and that's all we have to do there. The reason for that is because of the fact that RIP is a class, well, even though we went to class list, there's no way to type in a wildcard, so we'll have to just go with that. Same thing on 27, config T router RIP version 2 no auto, and then we'll type in, we're going to do, now if you do here, and you go all the way down to the bottom almost, so validate update source, that's where the source validation comes from. So perform sanity checks against source address of routing updates. So what we're going to do is we're going to type in no and then validate source. Same thing on 26, and we're going to do, let me do a do debug IP RIP, and we're going to type in no validate source update. Now, with that being said, we should start learning in routes from the other router, because it's not going to we don't have to worry about going out there and I'm trying to think of what I want to say. because we're not on the same subnet, we should install the routes. So if I was to type in on 27, I never advertised anything. I'm going to type in network 10.0.0.0. So we go to 26. We should be getting an update in of that. So 26 will be doing that. 27. So we should be loading 27 in. We did. So we'll jump out here to show IP RIP or route, and we have a RIP route, right? So source validation is working, right? So that's the only route we need at the moment. Now, one of the things that we'll be doing in the full-scale lab is there will be a lot of internal routes advertised, and the reason for that is because of the fact that we want to simulate a large-scale network. Well, not doing that here, just getting it operational. So that's great. All right, so we got the validate updates. The source validation is working. We have two different networks, and we're exchanging routes because we're not verifying the source of where the routes came from. So next thing we're going to do is we're going to jump over. We're going to send and receive version 1 and 2. So where you would do this is you go underneath the interface. So interface gig 1/0, and you type in IP RIP, and then you were to type in let me type do you all. And what we're going to do is we're going to take a look at where it says send and receive right here. That means that you're going to which versions you're going to send and receive for. So IP RIP, and we're going to say send, and then version, and then you type in, it says 1 and 2. This means that you can send 1 and 2. So 1 and 2. Now the only way you can check this, and this I don't think it kicks in until 15.3, but you can type in do show IP protocol, and it tells you right here what you're advertising. Same thing on 27. We can do the same thing. So now if we were to do a debug, we'd be getting version 1 and version 2 updates. Now, one of the things that I want to do before we go any farther is on 27, I'm going to go to interface gig 1/0. I love having the little interface icons right there. Makes life so much simpler. IP RIP, and that's sending. We're going to type in receive version 1 and 2. Okay, so that means let's say for instance that router 26 has really old routers that only support version 1, and you want to be able to take those routes in, receive them, and send them on to 26 or 27. This way here, you'll be able to send and receive, and it's unidirectional. So 26 and send to 27, everybody's happy. Now, at the same point in time, we want to be difficult. Okay? And the reason why we want to be difficult is we want to go out and we want to set broadcast updates version 2. So if we were to type in IP RIP and do question mark, V2 broadcast means that all the updates that are sent to router 27 are sent to all 255s. So not 224.0.0.9, all 255s. So V2 broadcast, and the only way to verify all this stuff is using a debug. So do debug IP RIP, and you'll see this pop up here momentarily. Every 30 seconds it's going through, and what I'm going to do is while that's doing that, I'm going to go to 27. Put 27 back in where it came from. And normally I would do, we're going to do unicast updates. The only way you can do a unicast update is if you use the neighbor statement. Now the neighbor statement is going to be kind of, we're already peered, but I'll show you what that looks like. So we're going to type in router RIP, and we're going to type in neighbor, and then we would type in 10.26.24.26, which I believe is router 6's address, and there we have the updates coming in. 26, 27. What the heck is the address? .24.26, correct. I do have the right address. So I could type that in. That's going to be unicast to the neighbor. So now what I can do is I can go out to 26, and now what it's going to do is sending V2 broadcast. So that is going to be our version 2 broadcast updates. And if we look here momentarily, we should see received version 2 update from, and let me lock this in here, this guy right here. Normally that would be 224.0.0.9, so if we pan up just a little bit, it would, let me grab this, scroll, so it's, where did it go? I just saw it a second ago. This thing doesn't like to scroll. Receive version 2 update. If if you look at the very bottom of my PuTTY session, it says right here, receive version 2 update from that address. That right there is it's going to be the neighbor statement. And if we scroll up just a little bit, receive version 2 update from... Oh, I didn't have the debug on. Let's go up here just a little bit. It should be up in here. Receive version 2 on 224.0.0.9. Where is it? I'm looking for it. I don't see it. Oh, you know what? Hold on a second. I never actually sent it. I never... Oh, I did apply it, so no neighbor. What this means, unicast adjacency, if I type in no, and I go back to 26, we'll receive right there. Or, hold on a second, it should be... if you have no neighbor in there, that means it's going to be multicast. And I'm looking for 224. Let's see, I don't see it popping in. And that's what... I'm sending a broadcast. Well, it's definitely. I know it's working. I would have to. Maybe 27 will say it. Debug IP rip. Show IP route. Oh, there it goes, right there. Sending v2 update to this guy. And that via loopback this guy. So it's sending the update via. What do you call it? Via multicast, and then go to global config router rip and type in neighbor 10.26.24.26, and then you'll see it flip over. It won't send it to this address, it'll be sending it to the unicast neighbor as soon as it flips over. Because that's the way it should work. And we were to do clear IP route star. Yep, see, sending hold on one second there. I'm just waiting for it to pop in. It might be, I may have too little bit of routing to go on. Yeah, it's still sending via 224.0.0.9. But it's sourcing it from this address. So yeah, it's normally the neighbor. Maybe it's got to be bidirectional in order for it to work. But that would be where you would go from there. So now what I want to do here is I actually want to enable it to where I want to set where when we go through our path selection, if I send an update from router 26 to 27, I want to make sure that all those updates come in with a metric of, you know, say 12 or something. So show IP route, we're receiving in this route, it's directly connected. So the loopback of 26 is coming in with that. So what I'm going to do is I'm going to go to 26. I'm going to go in, I'm going to type in router rip, and I'm going to type in offset. And if you type in 0, means for all networks, or you can use an ACL name. So what I'm actually going to do is I'm going to type in this. I'm going to exit out of here. I'm going to type in dude you all. I'm going to turn the debug off. IP prefix list. And this is where we're going to start getting into prefix lists. So I'm going to start just bringing in distribute lists and stuff like that to manipulate how we route. And I'm going to say this is going to be rip route. And the reason why I'm doing this is so that you guys can see how you can be specific to a particular route instead of doing all routes. going to type in sequence number is going to be 5, and it's going to be permit 10.100.26.26/32, and I'm going to hit enter. Now what I'm going to do is I'm going to type in router rip. I'm going to type in offset list. I'm going to say access. Oh, it doesn't do app prefix list. Root and tootin', or maybe it will. Rip route. I don't think it's going to work. Out. And then the offset. So we'll say 12. I don't know. I don't think that's going to work though. So if we look at this, and yeah, it did work right there. So now it's coming in as a metric of 13, and we were specific to that. So if we were to go to 26 and use a, let's type in interface loopback. Hang on a second. Let's do a do show IP interface brief. That's loopback 0. So loopback 100. We'll type in, or interface loopback 100. We'll type in IP address is going to be 172.16.26.26 32-bit mask, and we'll hit that. We'll type in router rip, and we'll type in network, and we'll type 172.16.0.0, and then we'll go to router 27, and then we'll see that route being propagated in, right? So, well, hold on a second. So then we'll see show IP route, and that one is being advertised with a metric of 13 as well. So it's catching everything, even though it's not supposed to, because it doesn't know how to not match it. So what we're going to say is we're going to go back to 26, and it's not the prefix list doesn't work. So we're going to say we're going to type in no, and what we're going to do now is we're going to say exit out of here. We're going to type in access list 1, and we're going to say we're going to deny or permit 10.100.26.26, and we're going to say /32, and we're going to go back to router rip, and we're going to type in offset list 1, and we're going to say out and 12. So now only the 10 network should be dealing with that. So now if we go show IP route, yep. So the 17. So the yep. So if we were to, you all. All right. So the way this looks right here, the 10 network is coming in as a hop 13, and the 17. This guy is coming in as a hop count of 1. So you can be specific. So we're permitting it to be offsetted, where this guy is not being permitted to be offset. So it's actually going through as just a 1 hop away. So the hop count is 13 in this case. So that's an offset list. Now auto summarization is turned on by default, and it is bound to the classful range. So or the major range. So if your major range is 155, and it goes based on class. So if your major range is 10, then it's going to block you down to the 10 network. Now if you're 172.16, that's a major range. 172.15, those are two different ranges. So in our case here, we're running, well, not in this case, but normally I would be running the 155.1 and the 150.1. Well, or the 150.1 and the 155.1. Both of those are major ranges because of the way that they're broken down, because of their class that they fall inside of. So with that being said, if you're going to do manual summarization, or if you're going to do a manual summarization, you've got to be careful with how you set that up. Make sure that you're encompassing the right amount of routes where you need them. So what we're going to look at now is doing auto summarization, which technically speaking it does that by default. So if we go to 26 and we type in auto summary, then everything we get from 27 is going to show up as soon as it clears the routing table here momentarily. During the next routing update, we should get Yep, see, this route right here is about to die because it's specific. And notice how all of our more specific routes are still there. Ten, 10, 27, 27, 10, 10, 10, 10, 10, 26, 26. They're still there. They're just being... What'll end up happening now is this guy will get aged out because he's a remote router, and he'll be... this guy will actually be timed out, and he'll be brought back to this because this is his classical range. This is the specific route. So that's one way to do it. Manual summarization would be to take on 27 and go to config T and type in interface gig 1/0 and type in IP summary address RIP and say what the IP address is. So we're going to type in it automatically will do 10, and then it'll break these down. So if we want to encompass this into one major route, we can, which would be 10.0.0.0, and what would the network mask would be 255.0.0.0, right? So we send that summary address down to 26. We jump down here, we do a show IP route. Once this timer concludes, we're going to be getting this RIP route. This is what we advertise as a summary route from router 7. So these other routes, I'm not sure if they're going to stay in. Yeah, they're going to get aged out. So let's do a clear IP route star. And the reason why this is going to happen is because this is a more specific route from 27. It's going to be encompassed in this route. So we're going to hit that and then show IP route. And so that route is no longer there. It's just the specific routes that are being encompassed by that. Actually, it hasn't learned it yet. It will, because it was learning the RIP route via that. So it's going to take a couple seconds for it to... There it goes. So right now, all we're learning from router 26 or 27 is the classical route, because that's all we've advertised over. We've advertised a 172 and a 10 network just so I can show you the difference between them in the classical boundaries, but all we're receiving from router 27 is a 10 network. That's it. So if we wanted to ping 10.100.27.27, we're not going to know how to get there, which should be working. Oh, you know what? 26.27. Show IP interface brief. Yeah. Show IP route. Does it know how to get back to where it's got to go? Yeah, it should know how to get there. 1020. No, it doesn't. Well, it knows it via this. This is possibly down here. Let's do a clear IP route. And then do a show IP route. Let's let it reconverge. And the reason why it does this sometimes is, well, it's RIP. Nothing yet. There it goes. So we're getting the summary from there, and we're also getting the 1020. So let's go to 26 and source it. But we're going to source it off of our loopback 0. And he should have this network in there, and he does. I think it might have something to do with that validate update source thing. I think that might have something to do with it. So I mean, it will form a neighbor relationship, but I've just never had good luck with it in GNS3 trying to actually peer. So let's actually change that over. Let's do a show IP interface brief. Now let's modify here on this guy. So we're going to go to global config interface gig 1/0 and type in IP address is 10.26.27.26 and do that. So that should take care of that router RIP, and then validate update source. Let's do the same thing on 27. So config T router RIP validate, and then that should take care of that problem. Now we go back to 26 and draw show IP route. We're there, and now we have clear IP route star. And we're learning that 10 route, and so now we should be able to ping 10.100.27.27 if we, yep, there it goes. And then if we source it off of our loopback 0, he should be able to get there. So it's just something weird with that validate update source. I've never been able to pinpoint what the exact problem is, and going from there. So right there, that's getting RIP operational. So far we've covered getting RIP initialized, getting an offset list configured. So it's a very basic path selection, or not path selection, but I mean, it could be path selection. You could make one route less preferred over another if you wanted to do that. And the way you would do that if you wanted to make path selection, if you had two different routes, so let's say you had one route was more physical hops away than somebody else, you could make the shorter path less desirable than the longer path just by modifying the offset list and just saying I want to modify that. And it works, I believe it works with RIP or EIGRP and OSPF. So that's this video here. I've gotten through all these guys. We'll finish up the this section with authentication convergence timers. We won't be able to do triggered updates because that's not a supported command in the operating system that I'm running on. And I'm not sure, and I know it goes underneath the interface, I just haven't been able to. Maybe it's a hidden command. Interface gig 1/0 IP RIP triggered. Yeah, it doesn't know that command. So that's just weird. Anyway, so we're gonna deal with that. We'll get authentication, convergence, and filtering going. Filtering, I think, will be its own video, which I think I'm gonna. I will jump around. I'll actually put I'll put filtering at the very end because it's there's such a big piece to it. I'll do authentication, optimization, scalability, and then I'll do default routing and also in the next video. So I hope you guys have found this informative, and I'd like to thank you for viewing.